what's going on? This is Keeping It Real Fishing, and as you can tell from the title of this video, today I'm going to be talking about Daiwa's Magforce braking system. Now, I find Daiwa's system here really interesting, and over the years, as I've looked at different Daiwa reels and I've read about them, I've noticed that there were different designations. There's Magforce, just regular Magforce, and then there's Magforce V, Magforce Z, and then most recently there's Magforce 3D. So all these different braking systems. One of the things that's really unique about Daiwa's Magforce system that I think maybe a lot of people aren't aware of is that it is in a way a hybrid system, in that it's mainly a magnetic system, but also in some of its iterations it's also a centrifugal system, and I'm going to show you what I mean by that. So the purpose of this video is we're going to look at a couple different Daiwa reels here, and each of these employs a different type of Daiwa's Magforce. If you ever wanted to know what it is or want to know how it works, I'm going to talk a little bit about that, and I'm going to open up the reels and show you mechanically what's happening with this braking system from Daiwa. It's a very, very good system, and yeah, depending on how it's set up in different reels, it'll run the gamut of being able to cast light lures through heavy lures very well. It's my preferred braking system, having used both centrifugal and magnetic. Alright, so let's start. This is a Daiwa Zillion, and this is a T3 Ballistic, and I'm going to move those out of the way temporarily so we can take a closer look at the Daiwa Lexa. Now, let's just get right into what we want to look at, which is this Magforce system. We have to pop open this side plate here. Now, for anybody who's watching who's unfamiliar, one of the benefits of a magnetic system, an all magnetic system, is that you don't have to take off the side plate to make any adjustments. So the classic example, I guess, would be Shimano. A lot of people like Shimano reels, and so you have the VBS system on the newer reels, but even older reels use that pin system. Very, very good system. I have a Shimano Chronarch. I like it a lot. I just happen to prefer the magnetic system. And one of the things I like about it, not only its performance, but I like the fact that my reel stays closed. I don't have to open it up and make adjustments and close it back up. It's not a major inconvenience, but to me, it's just nice that I don't have to mess with that. Just very quickly I can turn a dial and make changes, so I like that. Alright, let's open this up and take a look. Okay, so that screw is going to pop out. Just so you know, this screw is spring loaded, and so it's not ever going to fall out on you. You don't have to worry about losing it. Alright, let's take off the cap. Now there's two components to Magforce. One is the magnetic system in the non-handle side plate. So there's the magnetic system. Okay. The other part of it is the spool, obviously. But what's maybe not so obvious is the basics of how it works. Is this right here is usually referred to as the inductor. In this case, though, this inductor is fixed, which is different than many systems. And here's one of the hallmarks of the Daiwa Magforce system, and just Magforce, with no letters or anything after it, no Magforce Z or V. If you see a reel that says, that it employs Daiwa's Magforce braking system, this piece here is going to be stationary. It's just simply part of the spool. And this ring here is what's going to fit inside there. Okay, and so as you can see, now those magnets have the opportunity to exert force on this portion of the spool. A little different than if you look on, say, like a Bass Pro Shop reel. You'll see like little magnets in a row, but the idea is somewhat the same. This, rather than exerting a force like the Bass Pro Shops reels, they're flat and they're exerting it in a dimension like this against the flat portion of the spool. This is, while it's not Magforce 3D, it is a more three-dimensional approach in that this inductor here is contained wholly inside the magnetic field in a rotational application of magnetism. And then so what happens is, and I can't tell you the exact specifics, but as you turn this knob, you're going to be changing the magnetic field. In here are magnets, and as you rotate it, you know how magnets have poles. Well, you're kind of messing with bringing things closer and farther, and you're accentuating or lessening the effect of those magnets interacting with each other, and thus how much they affect this spool here. Actually, you see it got a little oil on me there. So this is regular Daiwa Magforce, and it works just fine. One of the criticisms of the magnetic braking system is that some people say like it's always on. So that even when you turn it to 0, it's not the same kind of free spool as you would get in a centrifugal system. Having both, I can't, I don't know. I prefer actually like flipping and pitching type things. I have more success with this style. I feel, you know, maybe my thumb is not as good. I know some people are really good at thumb and they say like, you know, a quote-unquote educated thumb. For me, this is just easier, and my distance for, you know, little flips and pitches just fine. So I can't say whether or not there's any magnetism exerted there when this is at 0. I don't really have a way to conduct that test right here. But practically speaking, out on the water, I don't find that when this is on 0, and of course if I'm flipping and pitching, if I have my spool tensioner loosened up, I don't feel that there's any noticeable resistance on the spool such that I can't do what I need to do. Alright, so let's put this one off to the side. That's a regular Daiwa Magforce. Let's put that back together there and just throw it off to the side. Now let's look at the Daiwa Ballistic. This is the Ballistic, the T3 Ballistic. Different than the T3, which is a higher end reel, but they both employ the same exact braking system. Alright, so let's take a look at physically what we have here. We have this dial on the outside, and there's 20 steps to it. I'll just give you a little extra information here. There's 20 steps to that braking system. Alright, let's take a look at this guy here. We're going to open him up by pushing down on that button. Swing that plate off, and here you go. Very similar to this plate, but at the same time a lot more intricate. So you can see the kind of the meat and potatoes is the same, but there's a lot more going on. Alright, so this is going to be the 3D system. Very, very cool system. And this is not something that I would say is hokey. I'm always kind of critical of when something new comes out, and you know, is it really just to impress us as fishermen, or does mechanically, physically, is it something new, is it something different? And this is real. This really has a very noticeable, tangible effect. So if you look at the bottom of the reel, I'm going to put this on real quick here just so you can see what I'm talking about. You're going to see you have some choices here. You have max brake all the way to the left, you have all around in the middle, and you have long cast up there where it's set right now. And so, pretty cool. Right there on the bottom, you have this switch. Now what that allows you to do is very, very quickly, in just one flick or two flicks, to alter the profile of the magnets. Now, you may already be familiar with this, but let me show you if you've never seen this. It's the same premise as before. The inductor of the spool is going to ride in that groove. Okay? But now we could change the nature of that groove. Let me show you. Now we're on long cast. Now watch. I'll try to hold it still. You see it comes out a little bit more and a little bit more. So now we're on max brake, all around, long cast. That's not, it may not look so impressive seeing that thing just move like a millimeter here and there, but in terms of a magnetic field, it is big differences, and you see that immediately upon casting it. If you have it on long cast and you knock it to max brake, huge difference in your castability. Max brake, of course, does have its place when you have a headwind or you have some light lures. You do want to up that brake a little bit, but while it may not look like it's moving a lot, the net result for you as fishing and casting is immediately apparent. Now there's two components to the 3 the Magforce 3D system. Now here's the interesting part, and this is something that if you're not familiar with, I want to enlighten you to. This is different than on, say, the Lexus spool. Daiwa uses this on most of their going from the mid-range and up, they all use the same type inductor, or design of inductor. So rather than a fixed inductor, they use one that's spring-loaded. Okay, so why is it spring-loaded? What's happening there? Now, this is really, really interesting because I was mentioning earlier, this is a hybrid system. This inductor, by centrifugal force, when you first start the cast, it's back. It's where it is now. And then as this, the first couple revolutions, it hasn't created the inertia yet. And as it goes faster and faster, this inductor here will actually extend out on the shaft more into the magnetic field. So it's kind of like a perfect marriage. You don't have the magnets encompassing it all the time. When it's needed most, when the thing is at the highest, when the spool's at the highest velocity, this will be out the furthest and the furthest into the magnetic field here. And then as the spool starts to slow, it will recede back in. Now I'm going to open this up for you and give you a first-hand look at how that works. I'm going to pause it just for a second because this might take me a minute. There's a little C-clip right here, and this is a retaining washer on the spring. And one of my questions was, when I started kind of researching this braking system, is I wondered what causes this to go out. I understand inertia, but this thing is spinning in this manner. So here's the point, here's the axis. It's spinning like this. Why is something going to go this way when it's spinning this way, right? I mean, you think about pins on like the Shimano system, they go out in this way, right? They go out to the edges. But this, rather than going out, is going that way. Sorry if that's confusing, but I think you get what I'm saying. What makes this go this way? Okay, well, it's pretty interesting, and I'm going to show you. So give me just a second to open this up. Alright, here we go. Here's the inside. Let's zoom in. You can see I took that little C-clip off. We're going to take this little retaining washer out. Actually, what I'm going to do is just flip it over. And there they are. Very, very small. I don't advise you to do this yourself. I'm not endorsing it. They're very, very small parts. I don't know if this voids your warranty or anything. If you're comfortable getting into the nitty-gritty of your reels, that's your call. You want to also be very careful here, because as you're trying to take them out, there is some chance that you could hit this inductor, and you don't want to do that. You don't want to scratch that. Alright, so now you can see that spring. Now let me take this piece out. Hopefully this all stays together. Okay, part of it fell apart. Now the inside, there's not a whole lot to see. Let's get that zoom going again. Or the focus, rather. So there's the inside. Here's the interesting part. I have the inductor. Let me put this other thing back on here. So in my hand is this little plastic piece, and it's cut in a very specific manner. I'm going to just put it right back where it came from, and there we go. Okay, so let's get some light on that. Here you go. Here's your inductor. This is the heart of the Magforce system, whereas the inductor moves. How does that inductor move outwards on a device that's rotating in this dimension? Well, here's how. If you look at these little plastic tabs, it's at the same time simple and extremely sophisticated. If you look at the cut there, you look at that angle, there's less mass here than there is all the way to the edge. That's heavier relationship wise than this part of the plastic block. Now it's all one piece. You see, you could just take these off. There it goes. just a little piece of plastic. Actually, it's probably not just any piece of plastic. It is, for its size, relatively heavy, I can tell you that. Not enormously slow, so it is just a small piece, but it feels appreciably heavy as a little piece of plastic goes. Let me try to rotate that. But you could see how it's that slope there, and that slope is what makes this whole system work. As this thing, you got to imagine now, this is spinning. This is attached to the spool, and this thing is spinning very, very fast. I have to hold on to this, so I can't really spin it in my hand. But as this thing is spinning, this heavy portion here wants to go out that way because of where the mass is located. If this was balanced, if there was no slope going up here, if this was just flat on top, it wouldn't do much of anything. It would be in perfect harmony, and centrifugally it would just, it would be here, the other one would be on the other side, and they would kind of counteract each other, and that would be that. But because of that slope, inertia wants to take this edge and push it outwards. It wants to push it that way, and so it does. As the spool is spinning, and this is spinning with it, it creeps out a little bit. It goes out from the spool. Let me see here, so you can kind of get that idea. This is on here. Let's go focus. And of course this is all, has the spring and the retainer and everything, so it can't go flying off. But that spring gives it the right amount. It's a very particular spring, as you can imagine. The amount of resistance in that spring is just enough so it doesn't fly out too quickly, but it's light enough, and it's in relationship to the mass of this piece of plastic. The spring and little piece of plastic relationship is critical to make that spool to make this at a given speed come out and extend into this piece, into the magnetic field, and then as the spool starts to slow, to come back in. But to you, it's seamless. It's not herky-jerky. You can't tell when it starts and stops. It's just absolutely fluid and seamless. So that right there is the heart of the Magforce system. This is utilized on the Magforce Z, V, and as you can see here on the ballistic, on the 3D. The only difference with the 3D is just basically your ability to make lump changes, very big changes quickly by altering that magnetic field via this switch, and then being able to fine-tune it with your traditional knob. So as we're going to see next in the Zillion is basically the same thing. It has the knob here, it just doesn't have this 3D system, but it still has the inductor that's on a spring and goes in and out. So anyway, this is the ballistic, and that right there is the mechanism behind how the centrifugal portion of a magnetic braking system works. I'm going to put this back together and I'll be right there. We go. Got it reassembled. Got that little C-clip back on there. And then as you can see, there's our spring. Okay. Put him away. Now lastly, let's look at the Zillion. Now actually this one here, the T3, is the most advanced of the three, even though the Zillion is a more expensive reel. Daiwa reels utilizing the 3D system. This is the most intricate of the three systems, but it's not to say that the system in the Zillion is inferior or doesn't work necessarily as well. The main thing is that inductor being able to move. That is the heart and the soul of the reel, being able to start up quickly, not have the magnetic field in the beginning, to have the magnetic field when it most needs it, and then for it to trail off automatically as the spool slows, all on its own. So that inductor on the spring is the main thing. The cool thing about with the 3D system is just the speed at which you can change the magnetic fields to go from a long cast to a regular and then to a max break. But it doesn't actually benefit you in terms of a casting distance. It doesn't make it any less magnetic, or it doesn't hinder you in any way. It's just the ability to change things quickly. Let's take a look at the Zillion. So before I open it up, same type deal. You have that wheel there, and this one here goes up to 10, but they're also in 2 steps. There we go. Slide it down, take it off. Now this one here is going to look really similar, pretty much identical to the one on the Lexa, because it really is the same. There's not a whole lot of difference here. I don't know if there is really any. I mean, they cosmetically a little bit different, but the internals, I don't know, but I assume they're pretty similar. I can't imagine too much being different here. So this one, though, different than that one with the fixed spool, this one with the rotor and then lots of adjustability, or the moving rotor. Now here's the Zillion spool, and this one also. Now this is the Magforce, which one is this? This is Magforce Z, and this is what we're seeing now from Daiwa in, I believe, all their domestic reels is the Magforce Z system. So you can see there's your inductor, same type setup, and here's the spring. Now there's subtleties here. I'm not an engineer, even though I'm into this kind of stuff, but there are subtleties here in terms of differences with these inductors. For one, on the ballistic, the amount of play, the amount that it can move is great, probably twice that on the Zillion. So if you look at how far it extends, let's get the focus going there. See how far it extends versus might look similar, but here in my hands, even though I haven't measured it, I can tell it doesn't come out as far. The other thing is resistance. I can feel a little bit of a difference in this spring. This one is a little bit, very little, but that little bit makes a huge difference in terms of these things. This one seems to be a little bit easier to pull out than that of the ballistic. So this one has more range, but a little bit more reluctant to come out. This one doesn't have quite the amount of range, but it does come out a little bit easier. What exactly does that mean in terms of performance? I can't really tell you. I mean, as a whole, I love both these reels. You know, for real world applications, you tie on a lure, they both cast really far, they both cast really smooth. Once I have these dialed in, I find that I don't backlash a lot, you know, in general, but I backlash almost none with these Magforce systems. I wouldn't be able to say like this one is appreciably better than this. I can't really notice the difference in usage, but mechanically there are subtle differences here. So this one goes into here, and yeah, and as you can see, this one doesn't move. It's just a normal fixed field, but the inductor will be moving in and out of that field. Alright guys, so those are the types of Magforce systems employed by Daiwa, and I'm just going to show you, I'm just going to use a visual aid here. I happen to have a Daiwa catalog, and just kind of rehashing what I just said here. This is referencing the Magforce 3D. This is also used on some of their higher end Z series. These are very big reels, and you can just kind of see there what I've been explaining. If you look at the field, max break, the amount of magnetic field applied versus all around versus long cast. And you can see this black area representing the magnetic field. There, it's almost not, you know, it's just really not on the inductor at all. Here's a little bit, and there's a little bit more. Okay. And then the last thing I want to touch upon in this video was I was mentioning that there was 4 types: Magforce, Magforce Z, which is what we see here and here. Actually, this is 3D, but the This portion of it is kind of the same. There's another one which is called Magforce Z. And let me just clarify that. I have seen some rumblings on internet forums and people kind of chiming in with what they said it was, and I wasn't sure, so I called Daiwa. I asked for technical diagrams, which they said they didn't have to provide me, but I spoke to an engineer type guy over there who was very thorough. Magforce V is simply, in some of their finesse applications, the spool will have a V cut. This is true of many manufacturers. You'll have a shallower spool, and rather than a flat spool, it'll have, it'll be V'd. Here you'll have material, and here you'll have material, so the spool will be a V cut. Doesn't hold as much line, and the idea is to not have as much weight on it. It starts up faster, etc. In the Daiwa reels where you see a V cut spool, that will have the Magforce V. And there is some subtle difference in terms of the inductor and, the resistance by which it comes out and how far it comes out. I couldn't tell you what they are, but that's, if you ever see those two designations, V and Z, that's the ones you're going to see them on, are the V-cut spools. Now, just as an aside, looking through a Daiwa's entire 2012-2013 catalog, in the US market, this is not true of the Japanese market, they have a lot of other cool models over there, but in the US market, for baitcasters, there is no Magforce V being utilized. The Stees, the Z series, it's still the, here's the T3 ballistic and the T3. The Pixie, I thought might have it, but it doesn't actually. It has a flat spool, but I double checked just to make sure, and this is the Magforce Z system. There's our Zillion. He also uses the V, Zillion Coastal. And then as you saw, the Lexa does not employ either the Z or the V. It's just traditional Magforce. And then we have some of the lower end ones, and those would not be utilizing any of those systems. Those are just going to be the regular Magforce. So, hey, I hope you learned something. I was always kind of curious as to what Magforce was and how it worked. If you made it to the end of this video, I applaud you. I'm sure that I stumbled saying V and Z probably interchangeably a few times. It's tough with all these terms. And I know this is kind of just technical and a lot of abstract stuff here. But hey, if you ever wanted to know, I didn't see a video on YouTube. I've seen kind of back and forth on discussion forums. I'm certainly not the expert, but I did make the call to Daiwa, spoke to him for a while, and I wanted to make sure I was telling everybody out there accurate information before making this video. So that's it. That's Daiwa's Magforce system in a nutshell. Thanks.